Okay, I'll speak up a bit later. Hi, I'm Francois, and I'm going to talk about security and privacy on the web. Now, specifically today, I want to talk about both of these things in the context of users, that is end users, administrators, the people that maintain web servers, and then web developers as well. So let's start with security. Let's start with security for end users. Now, often on the web, when we add things to the browser, we need the help of web developers in order to bring the security of the web platform as a whole forward. But sometimes we can actually add things to the browser that make users safer immediately without needing to convince web developers to use specific technologies. Safe browsing is a good example of that. Safe browsing is in Firefox, Chrome, and Safari, and it looks like this. Basically, what it does is that when you try to go to a site that has malware or a phishing site, something like this, it blocks the page, and then it prevents you from going there. Of course, there's a tiny little, ignore this warning thing, so you can actually proceed if you really want to, but by default, it will prevent you from going there accidentally with a big scary warning. The way that it works is that it uses pre-downloaded URL hash prefixes. Now, what does that mean? Well, pre-downloaded, which means that when you go and visit a site, it doesn't send the URL of the site you visit to a remote server to check whether or not it's safe. Instead, we periodically download a list of bad sites in the browser. Now, we don't actually have a list of all the bad URLs in the browser folder, because that would be quite large. There's lots of bad sites on the internet. Instead, we hash the URLs. So if you know what that is, we use the SHA-256 hash for the URL. That's a lot shorter. But on top of that, there are still too many hashes. So we take only the first 32 bits of a 256-bit hash. So only one small portion of the hash, that's what we keep in the browser. And all of these sites, all of these hashes are about 2 megabytes or something like this in your browser. So it's pretty small. That's how the browser can tell. So when you go and try to visit a URL, it does this local check against its database and then decides whether or not to show that big scary warning. This list is updated every 30 minutes because it turns out phishing sites pop up all the time. Some of them are short-lived, so they get removed after a while. But the browser will poll the server every 30 minutes to download updates. So it doesn't download the whole list every single time. It just downloads the difference between the last time it did an update and now. There's another thing called server completions. Now, what that means is that when you actually have a match in your local database, right? You go to the site, we find it in the local database. Well, it doesn't actually mean that it's a bad site necessarily, because we only have a match on the first 32 bits of the hash, right, out of 256. So it's possible that in fact it's not a phishing site. It's just a normal site that happens to hash to the same first 32 bits as the phishing site that's on the list. So in that case, what we do, we need to make sure that it's actually the site that should be locked. And we go back to the server that provides us with the list. That's a server that's hosted by Google. And we ask, hey, what do you have that starts with that particular prefix? And the server responds with the list of full hashes that start with that prefix. So then we can do again the local check to see whether or not we should block the page. At that point, if we have a match, then it is for sure the right page. So notice that doesn't actually reveal the URL of the page that you're going to. And it also doesn't even reveal the full hash of the page you're going to, just the prefix. On top of that, in Firefox, we also add a couple of noise entries. So basically, when we go and ask for a particular prefix, we want to see all of the full hashes for that one. We also throw in 3 other prefixes that you're not visiting, so to kind of obscure which one of those you're really interested in. And we also use a separate area of the browser for all of the safe browsing connections. So list updates, server completion, all of that stuff happens with a separate cookie jar. So it doesn't get mixed in with your Gmail cookie or anything else that you might be doing on Google sites. Another thing here to note is that the list entries will all expire after 45 minutes. This is because safe browsing prioritizes availability over kind of security. The reason for that is what would happen if, for example, Google were to put, I don't know, Gmail on the list, right? They would probably not do that. They probably have little internal checks that look for things like this. But they could accidentally block a legitimate site. And if for example, their server was going down, then that entry could persist, and then people could be stuck not being able to access a particular site, like Wikipedia, for example, for a long time. And so instead, if the browser can't talk to a safe browsing server for whatever reason, then all of its entries expire after 45 minutes automatically. When you get an update, it refreshes, it resets all the timers. But the worst case scenario here is a site there's a mistake in the list for 45 minutes. In Firefox, you can control lots of things in the build config. Those are the things related to safe browsing. So if you want to disable malware or phishing protection separately, you can do that. You can do that over here. There's another component to safe browsing, which is called download protection. It looks like this, and it happens after you download a file. So you download a file, and then we make some checks to decide whether or not we should block that file, like if it's malware or something like this. It works like that. The first thing that we do is a local check. We have a pre-downloaded list of dangerous hosts, so hosts that are known to host malware. If the file that you just downloaded is on there, then we will block it immediately, and then we don't need to check anything else. Another thing that happens on Windows is that we check if we try to see if the file is signed, if that download is signed by a known good software publisher. So, for example, Microsoft, Adobe, common people like that. Then we just allow it. We stop checking at that point. We just assume it's fine. So that gets those two steps get rid of like the vast majority of downloads. It's either coming from a dangerous host, or is something that people download all the time, say like the Flash player. Then so if we're still going, then we look at, okay, is it actually an executable file? Like, is it a .exe? Is it a .dmg on Mac, etc. If it's not an executable file, we don't check it. We just release it immediately. Now, if we're still going, we're still not sure, then we do something else, and we send the file metadata to an application reputation server. That's a server that's hosted by Google, and we send metadata like the file name, the URL it came from, the size, the hash of the content. We don't actually send the file content, we just send metadata around it. And then the application reputation server will tell us, yes, this is safe, or no, this is not safe. And then we just, based on that, we will block it or not. Now, if you want so in this list, for example, you probably noticed that there is one step that sends the data to the application reputation server. The rest is all local checks. If you want to disable the remote check, you can. That's the first option there. Downloads.remote.enable. Some people that are really concerned about their privacy might want to do that. But if you disable that, you still get the first couple of checks. The other stuff at the bottom here is something that we added recently in Firefox, but that you can turn on manually if you want to. This blocks two other types of malware. So basically, the application reputation server will tell us this is a dangerous file, this is a safe file, or it can also tell us this is a potentially unwanted file, or this is an uncommon file. So potentially unwanted means that it's not technically malware, but it's probably something you don't want. It's kind of like crapware or grayware. Like, it will change your default browser, it will change your search engine, or all sorts of undesirable things. When obviously, things that the application is not supposed to do, right? Like, if you download a new browser and it changes your default browser, that's kind of what it's meant to do. But if you download, I don't know, like a screensaver, and it starts to add affiliate IDs to all of your Amazon searches, that's the kind of stuff that gets on the list. Uncommon is just based on what the application reputation server sees. So if you go and download, say, the Flash player, that's something that people commonly download, right? But if you get a response from the application reputation server that says, oh, this is an uncommon file, I haven't seen it in a while, then, oh, maybe it's not actually the Flash player or VLC or something like this, right? It might be a Trojan version of it. So this is why these things are useful. If you want to know more about how safe browsing works, you can follow this link. I wrote a blog post about how it's implemented and everything. Yes?
So all those databases of hosts, app reputation, all that is maintained and fed and cleaned up how?
So the question was how are all of these databases maintained and created in the first place? On my blog post, I linked a couple of papers that explain basically Google has a team of people that work on this full time, and they have lots of machines that go around the web. And for example, they will like browse a website and in the VM and then detect, okay, if it's on Windows, like has the registry's keys changed as a result of visiting this website, right? If the answer is yes, that's a pretty bad sign. So they detect, they have lots of automated things like that detect, bad things. But you can read more about the details of those systems if you want. Yeah.
The fact that the browser is reporting many things that are being downloaded to Google seems like a very alarming privacy concern. I know the Tor browser bundle is based off of Firefox. Do you know if that functionality exists in the Tor browser bundle also?
It exists, but it's disabled.
Okay.
Yeah. So the question was, does the Tor browser enable safe browsing? And the answer is no.
You guys don't put in noise values or anything when you're sending the download metadata to Google like you do with the...
Do we send noise values for the download protection? We don't. No, we just send because we'd have to make them up. Yeah. It was the noise values for the browsing protection, the main part of safe browsing. Those ones are easy because we have them in the local database, so we can pull out real ones. All right. What about security for developers? There's a couple of things that developers can now use in the web platform to make the whole web safer. And one of those that's quite nice is content security policy, also known as CSP. The main mechanism the main idea behind this mechanism is that we want to prevent cross-site scripting attacks. And we do this by telling the browser, these are the things that you're allowed to load from this web page. Normally, a web page is allowed to load anything at all, right? It can pull in scripts from a random third-party server on the web. It could pull in images from somewhere else. Everything's allowed by default. CSP is about restricting this. Here's an example, right? Say you write a website that allows users to inject content onto your website, and then you display it to other people. What if someone were to type something like this, right? They write a message and then stick in a script tag. Now, obviously, if you write a web application, you're going to want to do some server-side filtering to get rid of that script tag. But what if you forget? What if you have a flaw, someone finds a way to inject the script tag? Well, without CSP, you get something like this, right? The script tag ends up on the page. The visitors come to your site with their browser, and the JavaScript gets executed in the context of your page. So you can do lots of things. With CSP, on the other hand, what you would see is this. So the message is still there, the script tag is still in the HTML, but as you can see here with the developer tools, CSP blocks it. It's not allowed to run, and there's a violation.
That's through the browser, not through the actual HTML or JavaScript on the web page.
So the question was, is this the browser actually doing the filtering? Yes. So this is enforced by the browser. The HTML does contain the script tag, but the CSP policy prevents the script from executing. And it looks like this. So CSP is a header. It's called Content Security Policy. And then you can define the things that are allowed to get loaded from that web page. So here, for example, we're defining that we have a directive called the script source, and that lists all of the allowed sources for scripts. So self is the website itself, right? The current URL. And we keep that, and also we add the CDN here. So that page can load scripts from both of these places, but nothing else. So inline scripts are right out, for example. You can control all of these things with CSV, the images, style sheets, videos, etc. Yeah, that's basically how it works. A related technology is strict transport security, also known as HSTS. This one is a mechanism to prevent a type of attack, type of downgrade attack called HTTPS to HTTP. And it works by telling the browser, never, ever, ever load my site over HTTP. Always load it over HTTPS. So this is important because of this really handy tool called SSL strip. Here's how SSL strip. Now, if you want to go to your bank, for example, bank.com in this example, and this is a normal case. We're not using HSTS. We're not using SSL strip. You type in bank.com in the URL bar, and that goes to HTTP. Because if you don't type in HTTPS, the default is HTTP, probably for historical reasons. Then the bank will hopefully redirect you to the secure version of their page, and then your browser will actually fetch that page over HTTPS. Now with SSL strip, it's a little bit different, slightly faster, because we skip the redirect, right? SSL script will just block the redirect, keep you on HTTP, so that it is able to see your keystrokes and all the stuff you're sending to your bank, or modify the pages as it wants. The great thing about this is that you're not going to see any certificate errors, because there are no certificates, right? The only way to tell that this attack is going on is to notice that the padlock is not there, which most users are not going to notice. So how does HSTS prevent this? Well, if you put in an extra header on your HTTP responses, called strict transport security, with one little parameter here, max age, some number of seconds, then basically that tells the browser, I'm available only over HTTPS, and please remember this for that many seconds. So the browser caches that information, and next time you try to go to the HTTP version of your site, so you type in bank.com in the URL bar, the browser will immediately go to HTTPS. It's not ever going to make a connection over HTTP for your domain. And so SSL strip basically doesn't work anymore because it doesn't have any HTTP traffic to tamper with. Here's another technology that web developers can use today called Subresource Integrity. Now, Subresource Integrity is there to solve a very common problem. That is, if you look at a typical website, say a news site, you'll find that they load a whole lot of third-party content. This is just one portion of the third-party stuff that this site is loading, just the JavaScript. And you can see there's a whole lot of stuff. Let's look at one of these entries. It's a version of jQuery hosted by Google. It turns out that's a pretty common thing to do for web developers because they can rely on a version of jQuery that Google hosts on their CDN, so presumably it's faster. But what would happen if someone were to compromise that file, right? To compromise that server? That file is included on a whole bunch of websites out there. Well, the answer, of course, is bad things. Someone could steal sessions, leak confidential data, redirect you to phishing sites, enlist you in the botnet, all sorts of things, right? Because they could take control of a whole lot of unrelated pages very quickly. But there's a simple solution. What if instead of doing this in our source code, what if we did this? We added the hash of the page that we expect to load, right? Here we have a SHA-256 of the version of jQuery that we're trying to load, and then so that's basically telling the browser, don't load this if it doesn't match this hash. And that's exactly the guarantee that browsers that support Subresource Integrity will give you. They will block the page if the hash doesn't match, basically. Yes?
I mean, isn't a version update something you would be expecting? I mean, so doesn't this kind of lock you into a...
So the comment is, what if you have to change you have to update the version of your JavaScript or the version of JavaScript is hosted somewhere else? Yes. So it doesn't work for dynamic scripts. In this case here of jQuery, you'll notice that it has a version number in the URL. That file is not going to change. And so for that particular use case, it's perfect. If you have something that actually changes often, then that's not the right technology for this. Yep.
Where do you get the hash if the vendor doesn't provide one, and how do you know if you have to make it yourself or actually
So
get a quality file?
you can go to srihash.org, which will generate the hash for you. It also gives you the OpenSSL command. You can, so if you want to do it yourself in the command line, you can do it as well. There's a couple of tools now that have the tools that kind of bundle together your JavaScript that have started to grow SRI support. So,
Thank you.
all right, let's talk a little bit about sysadmins now. HTTPS, right? Everybody loves it. Well, if you're not using it now, would be a really good time to start using it, because we announced almost a year ago that we want to deprecate non-secure HTTP. So obviously we're not going to turn it off overnight, but our plan is to get rid of it, whatever that means, at some point. So it's important because we've heard a lot of things from this man about basically how mass surveillance of all internet traffic is no longer theoretical. There are a couple of governments doing it. And so what that means really is that strong encryption of all internet traffic is also no longer optional. Right? It's happening all the time. And this is one of my favorite quotes. It stresses the importance of encryption. Bruce Schneier says that if you only encrypt the stuff that's really important, then encryption itself becomes a signal that whatever it is that you're saying that you're saying but we can't see, it's probably really important, right? So it's incriminating just because it's encrypted. But if everybody starts encrypting everything all the time, then encryption is no longer a signal. And so think about that. Every time you encrypt something, you're helping protect someone whose lives might depend on things staying secure. Yep.
It sounds like, though, that you're only counting on one element of security instead of having sort of like an onion where you have multiple layers for security. If you're just counting on the browser to do this type of stuff without other tools, lots of other tools, aren't you leaving yourself more vulnerable than?
So the comment was that security is more than just HTTPS, more than just the browser. And you're right. If you have malware on your computer, for example, it's pretty much game over. It doesn't matter if the connection between you and the web server is encrypted. The malware can just read it off of your screen, get your keystrokes, that kind of stuff. So yes, definitely, security is not just a browser. But coming back to HTTPS, another reason why it's really important is that your ISP is also spying on you, right? Those are the people that got caught. Comcast was injecting hostile JavaScript into your HTTP pages. AT&T was doing something similar. Cell phone providers, Optus in Australia, they would provide your phone number. They would add your phone number as an extra request header to any HTTP request that you made over the internet. Right? That's a little bit private. Verizon did basically the same thing with a unique identifier. Right? Again, they were able to modify HTTP traffic, so they're able to do this. Over HTTPS, they can't modify the requests, so they can't do this. This is a new project you may have heard of, started by DFF and Mozilla. Let's Encrypt aims at making HTTPS really easy for everyone, to take all of the pains away. And it kind of works just like this. Really, that's all you need to do to start encrypting your web server. It will automatically prove to the Let's Encrypt certificate authority that you own the domain that you're trying to secure. Then it will automatically download a free of charge certificate. So certificates used to cost money. Now they're completely free. And then it will monitor it and renew it before it expires. Because that's another thing, if certificates always expire, if you let it expire, then your site is no longer reachable. So a whole bunch of things that are easy to get wrong that Let's Encrypt aims to automate. But HTTPS is also not enough, because you need to configure it properly. You may have seen a couple of these things in the news in the past couple of years, things that were once believed to be secure and now are no longer believed to be secure. And the point that I want to make here is that things evolve pretty quickly in the HTTPS TLS world, and if you don't pay attention to these things, then you can run into trouble, because your server may be technically using HTTPS, but not really effectively encrypted. And so what I recommend is that you take a look at the wiki page that's maintained by our operational security team at Mozilla. And these are the guys that actually secure our own servers. And they keep up with all of the TLS news, and they update their configs constantly. And they always put the latest version of the configurations they're using onto this wiki page. There's also a nice little web app that you can use, where you put in your version of Apache or Nginx or AWS, version of OpenSSL, and then it will spit out the exact configuration that you can copy and paste into your configuration. Another thing you should have a look at is the Qualys SSL Labs site. This will allow you to test your web server. And so you can do this periodically. It gets updated pretty much as soon as a new attack is discovered, and it gives you a grade. The best you can do is A+, which you will get if you take the strongest configuration sample from the Mozilla site. The A is pretty good here. We'll also give you details if you scroll down as to what exactly might be wrong with your configuration. One thing to keep in mind when you deploy HTTPS is something called mixed content. That's a specification that's now implemented in all browsers. And what it does is that if you have a page that's hosted over HTTPS, say this one, this is the source code for that web page, you notice that here I'm loading two resources over HTTP. One is a script, one is an image. And the result of this is this. So the image is loaded, but the script gets blocked. And we see a warning, we see an error about the script being blocked and a warning about the image. Now, this is because if you're on an HTTPS page and you start to pull in a script you're on an HTTPS page and you pull in an insecure script, then that script can be tampered with and it can do whatever it wants onto the secure page. So you kind of lose it compromises the security of that page. For images, it's not as terrible as with scripts, so it's not blocked by default, but if you can turn it on and you can block mixed content images as well if you go into the settings. This is something I recommend in development, because then you don't want to have mixed content on your own website, and that's an easy way to detect it. Okay, let's talk about privacy for users. Now, coming back to that news site that we saw earlier, this loads a lot of stuff, right? A lot of third-party JavaScript. What is this JavaScript doing? Hard to say. But one thing we can say is that if you take a look at, if you browse that site and you browse other related sites as well in Lightbeam, which is a Firefox extension, you'll see on this neat little graph like this, you'll see all of the sites that you're visiting. Those are the circles in the middle. And the triangles are the sub-resources that it's grabbing from third-party domains. So essentially what you have is a graph of the connections between sort of companies or entities. And if you visit a second website, then you'll see another circle on the graph, and then you'll see, and then a bunch of triangles around that circle, and then you'll see the common triangles, right? The things they both include. And those people are the ones that can track you across these sites, right? And there's a really common tracker out there called Google Analytics, and that one is included in roughly 2/3 of web pages out there, so it can see a lot of stuff. Now, tracking is normally done via cookies. That's not the only mechanism, but it's the most common one. you can disable cookies, you can disable third-party cookies, those kinds of things. But these kind of approaches tend to break a lot of sites. Like disabling cookies is pretty impractical. Even disabling third-party cookies tends to break a lot of payment gateways, for example. So the settings that I personally use are these ones. Now, they're not exposed yet in the Firefox UI, so you have to go into about config. But what that does is that the second line here puts a maximum lifetime of 5 days over all cookies, so they don't accumulate beyond 5 days, because normally sites will say like, hey, this cookie lasts for like 5 years. So you can put a cap on this. And then it also makes all third-party cookies session only. So when you close your browser, it clears all the third-party cookies. Third-party cookies are typically for tracking purposes, not always, but the majority of them probably are like that. So that avoids those tracking cookies persisting beyond one session. You can read more about cookies on my blog as well if you're interested in the various toggles that we have. Now, Firefox also has something else to protect against tracking. This is a feature called tracking protection. It's enabled by default in private browsing mode. So basically, when you go into private browsing mode, it will actually kill the network connections of all of these trackers. So it's a mechanism very similar to safe browsing. We prevent those things from loading. And it uses all the same kind of safe browsing code, except that the one difference is that we don't have partial hashes here. We don't have hash prefixes. We have full hashes. So we download a list of trackers. It's entirely local, and there's no need to go to a server to ask for any full hashes because we have all the full hashes already. And this is the algorithm that the tracking protection code goes through. When you try to pull in a sub-resource for a page, we don't block pages, we block the sub-resources. So if the resource is coming from the same server, that's fine. We block third-party tracking, not first-party tracking. And so we just let it through if it's coming from the same server. If it's coming from a different server, then we look on the disconnect list. Disconnect is a privacy company that maintains a list of trackers. And so if it's on that list, then we keep going. If it's not on that list, then we proceed with the load. Now, if it is on that list, it is a tracker, we check whether or not the tracker belongs to the same company as the page that you're on. So for example, google-analytics.com technically doesn't have anything to do with google.com. There's no relationship between those two domains, except that they're both the same company. So we whitelist automatically the trackers that the particular company that so if you're going to Google, for example, then we whitelist the Google trackers. But if you're going to CNN, then it will get blocked. Google Analytics will get blocked from CNN. This helps with a lot of, it helps prevent breakage, but also it's not really third-party tracking if it's the same owner doing the tracking. So, and as I mentioned earlier, it's quite simple. We don't, basically we don't do anything special in tracking protection. We just kill network connections. When you try to open a new connection to the web server, we actually intercept that before the first byte is ever sent to the server, which means that the server never gets to set any cookies. It doesn't get to fingerprint you. Fingerprinting is the way that a lot of trackers will get around people blocking cookies. They will look at various information that your browser is giving away and then derive a unique identifier from this. So for example, they might look at your time zone, the list of fonts you have installed, the time that your browser is reporting, the language, all these things. And when you put them all together, so separately, none of these things are unique. But if you put them all together, they can be unique. There's a really nice project from the EFF that looks at how fingerprintable people's browsers are, and it's pretty scary. Yes?
So is there just a way of downloading a common fingerprint? So say, I would like this one that's used by millions of
the question is there a way to kind of override your fingerprint by downloading a common one so that everybody looks like they're running Windows 10 and using IE or something like that? There are a couple of tricks like that can be done. The Tor browser has a few of those. It's a little bit difficult to determine whether or not they work. And also, sometimes you can't really, like if you play with screen size is a big one. So you can report the wrong screen size, but then that will affect the display of the web page. So it's a difficult problem to solve. Which is why when you actually block when you block the network requests, it's great because the fingerprinting scripts don't ever get to run. And then you don't waste bandwidth downloading stuff you don't need, and everything goes faster because you avoid making a whole bunch of unnecessary connections. This is a setting that controls tracking protection in private browsing mode. This is probably the one that you want if you want to have it on all the time, not just in private browsing. This is something we're still working on exposing to users, but it works today if you flip it on. Yep.
Does the browser display when it's blocking?
Yes. There's some UI that says, elements have been blocked on this page and that kind of stuff. And if you want to know more about how it works, I wrote a blog post about that too. Right, so let me talk a little bit about privacy from the point of view of developers. There's a new specification that's being worked on called Referral policy, and that has to do with tweaking the referrer field. So the referrer, if you're not aware of what that is, basically anytime you place a request to a web server to get something, for example, you want to pull in an image from a web server, the browser will send the page that you're on along with that request. So if I'm on this page and I load an image from a different web server, then the other web server will receive the URL of this page. And it's basically like, hey, I came from here, kind of thing. So that could leak lots of stuff, right? That could leak, part of your, not really your browsing history, but part of it. But also, what if you're on the site and you say search for a serious medical condition, right? That becomes part of the URL because it's your search terms. Now, if you were to click on that ad there that goes to some insurance company, they would also get the referrer as part of that network request, because when you follow links, it's just like when you're loading other resources, you get the page that the user was on before they click the link. So you might be revealing lots of stuff that you don't want to reveal to them necessarily. But even worse than this, if that wasn't a link, it was just an image to an ad server, it would still leak the whole URL to the ad server. So you don't even need to click on anything. Just visit the page and it leaks all of that stuff. This has actually happened on healthcare.gov. They were leaking their referrers to dozens of trackers that they were embedding on their pages. So it's a real problem. And this is what the referrer policy is here to fix. Now, the referrer policy allows you to control on your page what the default referrer will be. So it can be no referrer, which is great. You tell the browser not to send any referrer to anybody that you load from that page. Or you can say no referrer when downgrade. That's the default. And what that means is you send a full referrer all the time, except when the page is on HTTPS and the resource you're trying to load is over HTTP. That's the downgrade part. Or you can send the origin only. So you send a referrer, but you just send basically the host name of the server that you're on. So you strip the query string parameters and the path and those things. Yes?
What's the purpose behind the referrer to begin with?
That's a good question. The question was, what's the purpose of the referrer? I don't know what the original purpose was, but nowadays it's used for lots of things, like ads. For example, they can determine where the ad was shown, things like that. It's obviously used for tracking. It's used for analytics. On your own website, it's quite useful because you can see kind of like, how people browse on your website, follow internal links and that kind of stuff. things you would have, you could derive from timestamps anyways in your access log, but that makes it a lot easier.
I've seen some websites actually use that to make sure that the workflow is going as expected, that you can't just jump to a page in the site without coming from a specific page.
So the comment was some sites will use that to kind of prevent you from deep linking into particular pages and will force you to go through a particular path. Yes, there's lots of annoying uses of the refer field. Origin, when cross-origin, so this one sends a full refer all the time, except if you go from one host name to a different host name, like one origin to a different origin, then it will strip it down to just the origin. So if you, for internal links, you'll have the full refer, but for external links, for example, then that site will only receive parts of the refer. And unsafe URL, you can probably guess, send the full refer all the time to everyone. Please don't use that one. The way you use it is you can either use a header. So this is again a response header where you specify the name of the policy you want to use. You can stick it in a meta tag in the page head, or you can also annotate links individually and say you can have a default policy, and then for that particular link you want no refer or something like this. Yes, question.
In the case where you have maybe using 2 or 3 of those methods, what is the priority? Which one wins?
So the rules are set in the specification, but the idea is that actually I'd have to check because the browser can decide, like the browser can decide what the minimum is, what the default is, those kinds of things. That's up to browser makers to do this. But then developers can say like this is a default and then override it for particular links. I think if you set it at the using the header or the meta tag, then that's the default one for the page. And then if you put it individually on attributes, then that overrides the default. So you can make it, you could say like no refer for the whole page, and then have the default no refer when downgrade for links.
My fear is that that you might say refer policy origin in the headers, and you want to enforce that on the page, but then some malicious JS comes in, finds all the A links, and adds in something and overrides it, and
Right.
now you have a fight between a system-wide setting that you want to enforce and something that may be intentional or maybe malicious overriding that anyways.
So the comment is you could have if you let if attributes are if you use if the attribute takes precedence over the global thing, then you might be thinking that you have an overall policy, whereas really some injected piece of JavaScript gets to change it. That's why you should use CSP to get rid of script injections. It's not
Okay. Gotcha.
like these things. Like if you have scripts injections on your site, refer leaks is probably the least of your problem. All right, let me conclude with a couple of recommendations for users, admins, and developers. For users, this is basically what I recommend. I've talked about the cookie, the first 3, the cookie settings. The 4th one, refer spoof source, is an interesting one. So I've just talked about what the refer is. This pref will not, so there is a way to tell your browser to strip out all the refers, just never send it. However, that tends to break certain sites that want to see the refer to make sure that you came from the right place or whatever. Often they will use it as part of the login flow. So if you disable refers entirely, like random things will break. This one is really interesting because it's equivalent to stripping out the refer, but it actually provides a valid refer all the time. So it lies about the refer, and it will always, so if you go from, say, if you go from foo.com to bar.com, then when you arrive, so you load an image that's hosted on bar.com from foo.com. When the request to load the image will go to the bar.com server, it will actually claim that it comes from bar.com. So it looks at the destination of the site where you want to go to and uses that as the refer. Yes.
Wouldn't that be another identifier though?
No, because it's all. Oh, you mean like as a fingerprinting thing? Oh, so the question is like if you start to lie about referrers, does that make you more unique as in the web? Yes, there's a lot of things where the more you deviate from the default settings of the most popular browser on the most popular platform, like you become more fingerprintable, right? Like using Linux, not using Chrome, using I don't know, like having no script installed, like all of these things make you a little bit more fingerprintable. So it's a really difficult problem. Tracking protection I've talked about. The next one has to do with obsolete crypto. So earlier this year, we tried to basically release this ref here to all Firefox users, but we ran into some problems where there were people that had basically out-of-date antivirus products that would man in the middle every network connection to check it, and while doing that, they were using SHA-1 certs, which are not legal anymore. They're not allowed anymore. So as of January 1st. And so we couldn't actually ship this to all of our users immediately. But unless you're using bad AV products, you can turn this on safely, and then it will actually disable brand new SHA-1 certificates in your browser. So, and if you are using bad AV products, then get rid of it and turn this on afterwards. The next one is something that I would encourage you to turn on in Firefox. It reports SSL errors to us. So this error that I've just talked about with the man-in-the-middle AV certs is something that was reported to us through this kind of mechanism, and we look at the data. It's really useful to us. So it's anonymous, but it will send us useful information that we can use to actually detect any problems with the networking stack. Yes.
What about self-signed SSL errors? They just generate additional data that's not useful?
I don't think that we send, so we don't send information about all SSL errors. It's just particular errors, and I don't think that we're interested in because that's not a very useful. It's not a very interesting error because it's just self-signed.
It is an error oftentimes when you're using self-signed products, whether you're in a testing environment, what have you.
Right.
I was curious if that's generating additional data that's being sent to.
Yeah, I don't believe we look at that. Yeah. We also don't collect URLs, so we will look at things like I think certain configurations that tend to cause problems in Firefox or in general with all browsers. But for the details, I would refer you to the source code. And finally, install the EFF, HTTPS everywhere. That's essentially a client-side version of strict transport security. They have a huge list of websites that are known to be available over HTTPS, and basically, if you try to go to these websites using HTTP, it will take you straight to HTTPS. So exactly like strict transport security, but built into the browser. And if you're really paranoid, there's a really nice project here about that's all about hardening Firefox and turning all the security knobs to 11, and it's lots of fun. You probably don't want to use that all of their settings because that tends to break quite a few things, but it's great for inspiration and to discover new things that you can tweak. Yes.
On the refer and the spoof source, is there a way to control like a whitelist of which sites you might want to allow to have the correct refer?
So the question is there a way to whitelist certain sites where you want to send them the real refer?
Right.
don't believe we have that yet.
Because there's some
Yeah.
sites, like I've had problems in the past with like Verizon, if when you're navigating the site, if you don't provide the correct referrer to certain pages, it will break the site, it will just not work properly.
Yeah, so there's a few places that break with reverse spoof source. In my experience, not many. It's a lot better than stripping it out entirely. But yeah, there might be a few things that break. All right, so for developers, it's pretty simple. It's the stuff that I've been talking about. So use SRI for all of your external scripts, the ones that don't change. Set a more restrictive refer policy, ideally no refer if you can afford it, otherwise one of the other ones. Consider enabling CSP. Now CSP, if you're trying to add it to an existing site, can be a lot of work, but for a new site, if you start with CSP from day one, it's quite a bit easier. Watch out for mixed content, because that will actually remove the padlock from your website if you care about that. And test your site with tracking protection. So just open up Firefox, go into private browsing, and test your site there. Because if you accidentally rely, say, on features provided by tracking scripts, then your site might break if the user chooses not to load those tracking scripts. For admins, basically enable HTTPS and HSTS on all of your sites. Doesn't cost anything anymore to do this. And use our recommended TLS configuration, because the defaults are unfortunately pretty bad. And test your site periodically with SSL labs, because these things evolve all the time. And if you want to keep an A grade, then you'll need to check this once in a while. And are there any questions? Yes.
Are other browsers as customizable as Firefox, all these little security settings?
So the question is, are other browsers as customizable as Firefox with without config? I don't believe so. I don't think that Chrome even Chrome has flags that you can turn on, but they tend to be for features that they're working on, like experimental things and stuff like that. I don't think that they have all of these options that they have. Like, the reason why we have all of these knobs in Firefox is because sometimes it takes a while to figure out how we can expose that to normal people. We could have pages and pages of security settings, and then people will have a heart attack when they open the preferences. Yes.
I heard some news about Mozilla possibly moving towards a Chromium-based browser. Is that something that everybody would talk about?
So the question is, I heard some news about Mozilla moving to a Chromium-based browser. Yes, there was like two news articles that said something like this. If you read past the headline, they would basically explained that was not the case. But the headlines were basically like, the future of Firefox is Chrome, and that's not actually the case. What this is based on is there is a team of I think six people or so that are working on UX prototypes for a next generation browser, but just like testing out user experience ideas. And they're currently using Electron, which is like a nice little Node.js and React browser API. That will not ever ship as a real thing. Like, it's just a UX exploration. And also, we have a team at Mozilla that's working on a Firefox version of Electron called Positron. So anybody that is using Electron will be able to easily switch to that. So no, the future of Firefox is not Chrome. It's most definitely Firefox. Any other questions?
Are you familiar with the plugin Ghostry?
Am I familiar with the plugin Ghostry? Yes. So Ghostry is an anti-tracking plugin, for those who don't know. It works basically the same way as tracking protection. It blocks network requests, and it uses a different list. But yeah, it's a very good plugin. Unfortunately, it's proprietary, but yeah, that's the on the outside.
How's Mozilla funded these days?
how is Mozilla funded these days?
Yeah, who's paying for all this awesome stuff you're showing us?
Yeah, so Mozilla is primarily funded through the search deal that we make, and currently our search partner in the US is Yahoo. So Yahoo is giving us most of our money. Yep.
So you mentioned earlier in the presentation that like scripts from the same like organization would be allowed through. How is that like determined, like whether it's from the same organization?
Right. So the question is about the whitelist of for tracking protection. There's a whitelist that loads scripts from the same organization. So we actually have a list of mapping like this. So for anything that's on the tracking list, then we map them back to the single organization. So tracking protection is really two lists. There's the list of trackers, and the whitelist that's associating trackers with their entity. Yep.
How effective do you think the security measures, the looking up in online databases of URLs are? The reason I'm asking is when I look at all the Windows users in my family that have support, most of them use Firefox and they still get malware.
Mm.
And then most of them don't go to what I would consider to be like bad websites. They just go to random websites and they still get infected.
Yeah, so the question is how effective really is safe browsing when we see family members running Windows getting owned all the time with malware. That's a good question. I mean, malware goes beyond just web pages, and also like safe browsing is not perfect. It blocks an awful lot of stuff. Our telemetry data is public. You can see if you're interested just how often those pages appear in Firefox and how often we block downloads. And those are really scary numbers. Like if we were to turn it off by default, it would be a lot worse. But yeah, it's really hard when you're dealing with people that have the threat is evolving all the time, and the Google team is working hard to keep up, but they're never going to be able to block everything. I mean, it's like people still get owned even though they have very expensive antivirus products, right? That's pretty tough. Yep.
This is a little bit off topic, but about a year ago, maybe 2 years ago, the Mozilla Foundation said they were going to start running some very high-capacity Tor relays in response to the NSA revelations.
Yep.
Do you know if those are still going on?
Yep. So we do. So the question was, Mozilla announced that it was going to run Tor relays, and we are running those. They're pretty large relays now. So yeah. We like Tor. Any other questions? No? All right. Thank you very much.
That was awesome. I am not a geek at all, and I understood most of it. And so I
thank
appreciate
you.
you put it to a level that we can all understand.
Thank you very much.
That was really nice.
Yeah, I like the talk too. Thank you.
Thanks.
I'm pretty freaked out by finding out that when I download things, the file name and the information about it and the metadata is all being sent to Google.
Yeah, it's so. Yes, I realize that. There's kind of three things I would say to this. The first one is Google explicitly